In this lesson, we're going to be solving this problem. This problem is under a compound shaft. So the problem statement reads as follows. A solid steel shaft with a diameter of 120 millimeters and 1 meter long is coupled to a hollow steel shaft having an outside diameter of 120 and the inside diameter of 80 millimeters. Then calculate the length where the torque is and the angle of the twist is, and we've given the modulus of rigidity. So here we are required to calculate the length. This compound shaft, it means, as here, if you look at this problem, it means that it is a series connection. Let me draw it. There's a shaft here. Like this, and there is another shaft in their joint here at the end. It's a hollow shaft. This is the bigger one. So this one has got the bigger diameter with a capital letter D, and this one is a smaller diameter with a small letter D. So this one, it's a hollow shaft. This one, it's a hollow shaft. This one is a solid shaft. They are joined in series here. Then we're given the length for a solid shaft. This from here to here. The length is 1 meter. Then we're not given the length for a hollow shaft. We don't have it. Because these shafts are in series, that means the torque for the hollow shaft is equal to a torque for the solid shaft. All are equal to the total torque. But when you are speaking about the angle of a twist, that means the angle of a twist total is equal to the angle of a twist of a hollow shaft plus the angle of a twist of a solid shaft. It is like this. You have to add these two to make the total. But here, the torque is the same throughout this. When they are connected in series like this, you use it like this. Then here, we are required to calculate the length. That means you're going to use this combination to find the length. Because here, the total angle of a twist, this one, the total angle of a twist, this one. Then that means the total, you have 3 degrees divided by 57.3. Then when you equate this, let us write this and this here aside. The angle of a twist for hollow shaft, it is equal to 10.2 times the torque times the length for a hollow shaft. The length for hollow shaft, then divide by a modular of rigidity times the external diameter to the power 4 minus the internal diameter to the power 4. That is the angle of a twist for a hollow shaft. Then the angle of the twist for a solid shaft, it is 10.2 times torque times the length for a solid shaft, then divide by modular of rigidity times the internal diameter to the power 4. Then let us move a little bit up. Then you can take this to substitute here. Take this to substitute here. Let us do it. For this, say it is 10.2 times torque times the length for a hollowed shaft divided by modulus of rigidity times the external diameter minus the internal diameter, all to the power 4. Then plus this plus then goes here. For the solid part, it is 10.2 times the torque times the length divided by modulus of rigidity times the internal diameter to the power 4. Just put it here. It is 3 theta. It is 3 theta 57.3. This is to convert this degrees to the radians. It's a conversion part. So proceed. Equal to then 10.2. The Tokyo, it's the same throughout, times the Tokyo. This is the Tokyo. It is 20 times 10 to exponent 3. Then the length, that length is the length that we are looking for, divide by modulus of rigidity, this 8. It is 80 times 10 to exponent 9. Then for the external diameter, it is 120 times 10 to exponent negative 3 all to the power 4 minus the internal diameter, this one, it is 80 times 10 to exponent negative 3 to the power 4, close bracket. Then we proceed, plus come this side, because it is this side. Now we come this side. It is 10. Let's move a little bit this side. It is 10.2 times 20 times 10 to exponent 3. That is a Tokyo. The length, it's 1 here. Divide by modulus of rigidity. It is 80 times 10 to exponent 9. Then we times internal diameter, 80 times 10 to exponent negative 3, like this, to the power 4. Now let us move down here. What we're gonna get? We're gonna get 0.0523 equal to this part. What we're gonna get here? We're gonna get 0.0153 length for the hollow shaft. Then plus this side, we get 0.01229. That's what we get here. Then gonna be the length for hollow shaft is 0.0523 minus this one. It is 0.01229. All divided by this 0.0153. Then this, it's gonna give an answer to be 2.60 meters. That is the answer that the problem statement is looking for. That is the length for the hollow shaft. This length, it is 2.6 meter. That's how you calculate this. You must be careful here. This, for the hollow shaft, it is the external diameter to the power 4 minus the internal diameter to the power 4. Here is for the solid part here. You see here where they are not the same. This side on the bottom, both sides are not the same. If the compound shaft is in parallel, it is, let me say, it is this. This is the shaft, a hollowed one, hollowed shaft, like this. And another shaft, it is inside here. It is inside here. It is stuck inside here. They are in parallel. This, it's a bigger one, which is external diameter. And this that they are inside, it is a internal diameter. This is in, it's a parallel compound shaft. This, it's a series combination compound shaft. this one. Then here, it's not the same like the series part that we're calculating here. It's not the same like that. Here, the Tokyo are not the same. It is the Tokyo total, it is the Tokyo for the hollow shaft plus the Tokyo for the solid part. But the angle of a twist, it's the same for the hollow shaft and it's the same for the solid shaft. It is like this. You see, it is vice versa now. For the Tokyo, it is not the same. The total, you have to add the Tokyo for the hollowed shaft and add with the Tokyo for the solid shaft. You add together to get the total Tokyo. That's how you calculate this. I just wanted to illustrate this because it is a parallel combination. This is a series one.